Good morning, my dear students. Welcome to my physics class. Our today's topic is electric potential. At first, we will see the flow of water. Suppose this is a water container. Up to this level, the water. Suppose another water container. A and B. A and B are two water containers. If we connect this container A and B container with a pipe, then in which direction the water will flow? Obviously, from A container to B container, the water will flow. As the height of the water in container A is higher than the height of the water at container B. Here higher water level and here lower water level. Therefore, water will flow from container A to container B. Here the amount of water in container A is more than the amount of water in the container in B. Now, if we take this container here, now the water level in container B is up to this and water level in container A is up to this. If we connect these two container with a pipe, then the flow of water will be from container B to container A, because the water level at container B is higher than the water level at container A. Here water level up to this and here water level up to this. Here the amount of water is more than the amount of water in container B. Therefore, the flow of water does not depend on the amount of water, it depends on the level or height of the water height of the water level. Here the height of the water level is higher than the height of the water level in container A. Therefore, water will flow from higher height to lower height. The flow of water does not depend on amount of water, it depends on height of the water level. Now we will see the flow of heat. Suppose this is a body A and another body is B. Suppose here 500 joule heat in this container and here heat is 100 joule. The temperature of the body A is 20 degrees Celsius and the temperature of the body B is 40 degrees Celsius. Here the amount of heat is more than amount of heat in the body A is more than the body B, and temperature of the body B is more than the temperature of the body A. Here 20 degrees Celsius temperature and here 40 degrees Celsius temperature. If we connect these two body, then in which direction heat will be flow, from A to B or B to A? Here temperature is 40 degrees Celsius higher temperature, here temperature is 20 degrees Celsius, that is lower temperature. If we connect these two body, then heat will flow from body B to body A, because the flow of heat depends on temperature, does not depend on amount of heat. Here the amount of heat is 500 joule, but here amount of heat is 100 joule, but its temperature is 40 degrees Celsius and its temperature is 20 degrees Celsius. Therefore, heat always flows from higher temperature region to lower temperature region. It is a hot body and comparatively it is less hot body. Therefore, heat will flow from body B to body A. Now, we will see the flow of charge. Suppose a body, if we accumulate charge in this body, suppose the body A is positively charged, if we touch this body with another body, we know the charge will flow. If we touch two charged body, then in which direction the charge will flow depends on which factor. Will it depend on the amount of charge or any other things? Actually, similar to the level or height of the water level and temperature, there is something on which factor the flow of charge depends. The flow of charge depends on a special factor. This factor is known as electric potential. Electric potential will determine in which direction the charge will flow. Suppose a body, it's another body B. Its potential is VA and its potential is VB. If we touch these two bodies are charged body. If we touch these two bodies, then the charge will flow from higher potential to lower potential body. Suppose here VA is greater than VB. Therefore, the charge will flow from A body to B body. But if the potential of B body VB is greater than the potential of A body, then if we touch these two bodies, then the heat charge will flow from B body to A body. That is, flow of charge depends on electric potential. Charge flows from higher potential region to lower potential region. As water flows from higher height to lower height, heat flows from higher temperature to lower temperature, and charge will flows from higher potential to lower potential. The direction of flow, if we consider the direction of flow of charge, then we can compare the potential with the height of the water level and temperature. Suppose it's a metallic sphere, its radius is r. If q amount of charge is given to this body and therefore its potential is V, then its potential will be V is equal to Q divided by C. Here Q is the amount of charge, V is the potential, and C is the capacitance of this metallic sphere. C capacitance. C is the capacitance, and C is equal to R divided by K, where K is equal to 1 by 4 pi epsilon naught for free space or vacuum, and its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. In case of free space, C is equal to R divided by K. Here V is equal, potential V is equal to Q by C, and C is the capacitance, and capacitance C is equal to R divided by K. Therefore, we can write V is equal to Q divided by C. C means R divided by K, R divided by K. This is equal to K into Q divided by R. That is V is equal to K Q divided by R. Now, consider two bodies of different radius. Suppose one body is this, its radius is r1, and another body, its radius is r2. Obviously r1 is greater than r2, r1 is greater than r2. If we give q amount of charge on both bodies, here q charge is given to the body A and q amount of charge is given to the body B, then according to this formula, its potential VA is equal to K is a constant Q divided by R1, and its potential VB is equal to K Q divided by R2. Its potential is Q divided by R1 and its potential is K into Q divided by R2. Here R1 is greater than R2. Therefore, R1 greater means VA will be less than VB, as R1 is greater than R2. Therefore, we can write VA is greater than, VA is less than VB. Potential of body B is higher than the potential of body A. Now, if we connect these two body, then in which direction the charge will flow? The charge will flow from higher potential region to lower potential region, that is from body B to body A. In this direction the charge will flow. That means the flow of charge depends on a special factor which is known as electric potential. Now consider a charged body. The body is positively charged. Suppose its charge is Q. This Q charge will produce a, an electric field around this charged body. If you consider another charge Q, suppose this charge is Q plus Q charge, this Q charge will produce an electric field around this charged body, and this electric field is suppose E. The body will produce an electric field E and its charge is Q. If you want to move this plus Q charge towards this body, then as it is positively charged body and its plus Q charge, then there will be repulsion between this Q charge and plus Q charge. Therefore, if you want to move this plus Q charge towards this charge, then we have to do work against this repulsive force. We have to do work against this repulsive force, as it is a positively charged body and here is also positive charge. We know the charges of same nature will repel each other. Therefore, we have to do external work if we want to move this plus Q charge towards this Q charge body. If we bring this plus Q charge to the Q charged body, then the repulsive force will be F is equal to electric field intensity E into Q, that is F is equal to E Q. Electric potential: the amount of work done to bring a unit positive charge from infinity to a point in an electric field is called electric potential. W is the work done to bring the charge Q, then potential is V is equal to W divided by Q. And electric potential V is equal to W divided by Q. This is the electric potential. If W amount of work is done to bring a Q charge from infinity to a point in an electric field, then the potential of that point will be V is equal to W divided by Q. Suppose this body is negatively charged body, then here plus Q charge, as this body is negatively charged and this is positive charge, there will be a attraction between this Q charge and this plus Q charge. Therefore, an acceleration will be produced on this charge plus Q charge. If we want to bring this plus Q charge slowly towards this Q charge, then we have to pull this plus Q charge, we have to pull in this direction. Otherwise, the plus Q charge will be accelerated due to the attraction force between negatively charged body and plus Q charge. We have to apply a force opposite to this attractive force. This is the attractive force and this is our applied force. When these two force will be balanced, then there will be no acceleration on plus Q charge and the plus Q charge will move slowly towards this negatively charged body. As the applied force and direction of the motion of the plus q charge is opposite, therefore here negative work will be done. Therefore, the formula of potential will be same W divided by Q, but in this case as the W is negative, external work done is negative, therefore potential will be negative. Here for negatively charged body the potential will be negative, and for the positively charged body the potential will be positive.